Hi, this is Irv Shapiro with MakeWithTech, and I'm dressed for the summer in the middle of the winter here in the Midwest of America. And the reason is I have a lot of work to do. I'm going to be assembling a massive printer. You'll see the parts in front of me. In fact, it's so tall that I'm probably going to have to use a different table to hold it once it's built, because the 7-foot ceilings in my lab are probably not tall enough. What is this printer? This printer is the Flsun V400. Now, I'm a very big fan of the Flsun Super Racer. Some people call it the SR. And in fact, I made a video about it where I inadvertently called it the Speed Racer because it was just so fast and I really enjoy using it. The disadvantage of that printer, which is the fastest printer I own, up until now potentially, is that the quality wasn't great. It was good, but it wasn't great. And the build area was just average. So the V400 potentially resolves all of those issues. It does it in a couple very interesting ways. First, and let me make sure I get this right, the print area is 300 millimeters in diameter, because it's a Delta style printer, so it's a round print area, by 410 millimeters high. That means the printer must be much higher than that because of the Delta mechanisms, and we'll see when it's fully assembled. Next, it has a brand new print head. This is a direct drive extruder. It is unbelievably light for a direct drive extruder. And it has an all metal hot end that's rated to 300 degrees Celsius. And then it has a very unique feature. There are these little strips of LED lights along the head so you can see what it's printing. I'm really interested to see how this does. But the feature most people talk about is this may be one of the first consumer grade or prosumer grade 3D printers that uses Klipper installed from the factory. You see, they've taken the Flsun Speeder tablet and they use that as the firmware controller for this printer. Now you can buy these Flsun Speeder tablets and use them to add Klipper to other printers, but this one is integrated with it at the factory. So I'm very excited to put this together and to look at both its characteristics from the point of view of speed, its ability to print very large objects, and to learn more with you about Klipper. So stay tuned and let's learn something together. Well, folks, over the last couple of days, I've had a lot of fun. I've had a lot of fun because I love learning new things. Now, as I explained in the introduction, this printer, this 3D printer, does not use Marlin, the traditional 3D printer firmware for FDM style printers, in particular consumer grade, prosumer, home, hobbyist 3D printers. Marlin's a remarkable thing. It's a piece of software written quite a while ago that allows you to use a very low cost single chip computer, an 8-bit microprocessor, assembled into a board that sells for $15, $20, $30, $100 to control a 3D printer. Now, Marlin had to be highly optimized to run on those small computers. Think of it as a house with one bedroom, one bathroom. But more recently, 3D printers have been using 32-bit control boards. Marlin was upgraded to Marlin version 2 that also supports 32-bit controllers. And it does a lot of additional things. But the speed of those single chip computers is still quite limited. Limited in computer terms to about 72 megahertz, 72 million hertz. Hertz, megahertz is like saying miles per hour. Nowadays, most of the computers we use around us, even our phones, our tablets, our computers, are measured in speeds of gigahertz, billions of cycles, instead of megahertz, millions of cycles. And in fact, the Speeder tablet that's used on the V400 is just a tablet computer. This could be loaded with other software and used as a tablet. But instead, it's loaded with a piece of software called Klipper. So instead of running at 70, 72, 75 megahertz, it runs at 1.6 gigahertz. And it's bigger. It has more memory. So with all of that extra power, the Klipper software, the replacement for Marlin, can do a lot of additional things. And it can allow your printer to print much faster. So let's take a quick look at the architecture inside this V400. I'm going to put a picture up here on the screen. I'm going to look at it here. You'll see here on the left side, you have the printer itself with the internal control board. And it has basically the same control board, a slightly newer version, as the Super Racer. But the Super Racer runs Marlin, and all of the work is done in that control board. In the case of the V400, just enough work to control the stepper motors, the motors that drive the printer, are done in that control board. All of the rest, the interpretation of the G-code, the instructions, the optimization of the G-code, the optimization of the head movement on your printer, the optimization of the flow of filament, all the rest is done in this tablet running Klipper. So Klipper is effectively the firmware. So if you look at the middle picture, you see that the Speeder Pad is running Klipper. It's also running two other pieces of software. One piece of software that allows programs outside of this tablet to talk to Klipper, to communicate with it. And then another piece of software, which is a user interface, a website basically, called Mainsail. So Moonraker allows computers that are not inside the tablet to talk to Klipper, and Mainsail is the user interface. Altogether, that gives you remarkable capabilities, because with the V400, you can control it from this tablet, which has a very nice, very easy to use touchscreen interface. Extremely well done. You can also control it from a web browser. And I'll show you some pictures of that because it's really quite fascinating. Okay, so we've talked about the architecture a bit. Let's step back and talk about the assembly of this machine. The assembly consists of putting these three rails on the base and the top and attaching it together. But there's one gotcha, and that is you have to run a wire, actually a bunch of wires, from the top to the bottom of this rail. And you have to run it in a fairly narrow channel. I tried just pushing them through. That doesn't work. So I happen to have an electrician's fish tape. So I ran the fish tape through, I taped it to the end, and I pulled it back through. You're gonna need something. It could be a stiff cable. It could be another more flexible cable, but one that you can drop through. You're going to need to run another cable through this channel, attach it to the cables that come with the printer, and pull them through. Now you've probably noticed this cable hanging here. Well, this hook and ring do not come with the printer. I added that on because you don't want to lose this. This is the auto bed leveling sensor. It's like a BL Touch, except it's not permanently on the head of the printer. Instead, you just clip it on like this. You plug this cable into the top. You go to the front screen and you tell it to calibrate the bed. That's going to initially sense the bed. Then you tell it to do a full ABL run, where it scans multiple points like other types of ABL. Then you take this off, and you don't want to lose it, So I took and I hooked it right here on a little clip that I just clipped on the side. Now, on some of my other printers, I actually run the auto bed sensing, at least a short version of it, before every print. Because on a bed slinger, the traditional types of printers where the bed moves back and forth, or an Ender 5 where it moves up and down, there's a lot of movement there. This bed doesn't move. The only thing that moves in a Delta printer is the print head itself. That's the only thing that moves. So unless you're moving the whole table around that the print bed is on, it's unlikely it's going to change much. Now, temperature impacts it. It is a removable surface. It's a very nice surface. Every single print I printed stuck without issue. But you probably only need to do that periodically. Probably do it once a week. Now, so you've assembled it together, and then you plug in the Speeder tablet. It just plugs in. It has a power connection here, and it has a USB connection. The other connections here are for other devices. So one of them I have plugged into a camera on a tripod because I can use this to create time lapses of my prints. Also, the instructions, videos about how to assemble this computer, a profile, the components of a profile for Cura that you can use both on a Mac and a Windows machine come on a USB key. Some people call these USB drives. This is a full-size USB device. It's not one of those micro SD cards. In fact, though, you don't need to have it plugged in to run the printer because there is 16 gigs of storage space in the Speeder Pad. And so you can copy things to that pad from a website because there's a web interface to this printer. Now I've gotten out my MacBook Pro and I've opened up Chrome and I've gone to the IP address of this device. Now when you configure Wi-Fi on this device, you go to configuration on the pad and then there's a configuration for network. When you configure it on the pad, I found it didn't actually access an IP address, grab an IP address until I told it to restart. So I selected my network, I put in my password, it seemed to work, but it wasn't really online. I did a restart and it came up online. Then it tells you your IP address. That IP address you put into Chrome. So in my case, it's 10.0.1.13. And that's what you use to access this printer. You're really accessing the tablet from a browser running on any other device. So I've been upstairs watching TV and checking the printer on my phone by just going to this address. You'll see here on the screen the standard layout. Now the layout changes a bit depending on the size of your screen. Down here, you'll see the webcam. See, this is actually the webcam that I have right over here. And you can use that to create time-lapse videos of your prints. Now, this Klipper interface has a lot of stuff. That's a whole nother video to go through that. But just to give you an idea, you have the overall dashboard, and you can scroll up and see additional sections here, which you can expand out. And then you have the file section right up here. So any file that you've uploaded to this computer, and you can upload files to this computer right by clicking on Upload and Print. So you have a file that you've sliced it from Cura, it's on your hard drive, you click Upload and Print, and it will send it to the printer. When you do that, you have an option to do a time lapse. You also can add a plugin into Cura to directly access this printer. When you do that, your files that you send to the printer from Cura also show up in the same list over here. I found one idiosyncrasy. When you select the option to send and start the print, it does not create a time lapse. Now, one of the things that's interesting is the time lapses are stored on the Speeder Pad. They're not stored in your computer. So this is a very, very powerful user interface. It's very much like Octoprint. It doesn't have plugins, but it does have the ability to do a lot of things that you would need to do directly from a computer over Wi-Fi without walking to your printer. And that's how I've been controlling this printer. Now, as I mentioned, you can do the same things by just following this very easy to follow tablet. Okay, so we've talked in generalities about this printer. 300 millimeters in diameter, 410 millimeters high. It has a direct extruder, all metal hot end, 300C. It has a filament out sensor. What it doesn't have is power fail recovery. Because let's think about it. Power fails, you need to have backup power on this tablet and on the computer long enough to save where you're at. And as I've mentioned in some other videos about how Marlin does that, it doesn't really work very well because it saves the beginning of a layer. And if you were at the end of the layer when the power went out, you're going to try to reprint that layer. That's not going to work very well. So the best way to get power fail protection for this device is to put it on a UPS. Now, if you've just spent almost $900 for this device, spend another 50 to 100 bucks and put it on a good UPS that will cover both of these devices. Okay, now let me reposition the camera so we're a little closer. It's easier for you to see. And then we're going to look at the prints I've created and answer the question, is this fast? Is the quality good? Why should you buy a $850 to $900 3D printer when you can buy very good printers starting at about $250 and up? Okay, I want to cover one more thing before I talk about these beautiful prints. I want to talk about what comes with the printer. So you do get a small reel of filament. I didn't use it. I like to use filaments I'm familiar with when I do my testing, but you get a couple other things that are quite interesting. You get an extra heating element. Now, I don't know if that's because, and this is a rather large heating element, it might be because since it can go up to 300 degrees C, these tend to burn out more frequently, but you also get an extra thermistor. That's basically the thermometer that measures the temperature of your printing. What you don't get is an extra nozzle. Interesting. And the nozzles on this printer, I have not looked at, so I don't know if they're completely standard or not. But most printers nowadays give you extra nozzles. You also get some grease specifically for these rails. Now the rails on this printer are different than the Super Racer, which uses linear rails. This uses wheels. And I don't know why they made that change. Some people speculate that they actually move faster than the linear rails. They have less friction. But we'll see as we go through these prints, it does not seem to impact the quality of the prints at all. Okay, now let's start with the prints that came on the SD card. Every one of them printed almost perfectly. This is a little mini calibration cube. You won't be able to see it very well here. But just to give you an idea, I will take and check to see what the dimensions are, if they're accurate. So we're going to check here. And this is supposed to be 20 millimeters. You can see this is 20.3 millimeters in that dimension. And in this dimension, actually, I had that wrong. I wasn't measuring. It wasn't the right part of the jaws. It's 19.8 in that dimension. And in this dimension, it's 19.78. So it's almost completely square in that dimension. There's one other dimension here, and this is 19.6. So this is pretty well calibrated. Now, just to be sure, I did print my own calibration element. It's called a calibration cat. That printed very nicely also. And that comes out at 19.6 by 19.6. so it printed very well. And I'll talk about setting up to print this in a minute. Then the next thing I looked at was this overhang test that was on the USB drive. The overhangs are really good. Now, it might be because there are two fans, two physical fans, one coming in from each side on this printer. And so that printed very, very nicely. Then I took and I printed this toy. This is about one of the most fun toys I've seen on a 3D printer. This is right on the USB key drive. It's not in a bolt. It's really just a toy. It printed very fast and it works perfectly, and it's a beautiful, beautiful print. Now, something I did notice is the bottoms were really good. The tops were okay on all of these prints. It's easy to tell what the top was. So you'll see a little later when I set up Cura, I slowed down the print speed on the top and the bottom just a bit. So the prints that came on the printer, all beautiful. Now, in order to print my own prints, starting with this calibration cat, I copied the individual configuration files that are on the USB drive to the locations indicated in the user's guide. It's also in the user's guide that's online and on your USB key, and directly into Cura. And they have a setup for Cura 4 and a setup for Cura 5. I used the Cura 5 setup and it worked just fine. Then I did two changes. I turned Z-hop off because in reading a lot about Klipper, it seems Z-hop and Klipper are not always working together perfectly. And I slowed the top and the bottom layers down to 60 millimeters per second, which is a little slower, to get a little better top and bottom layer. Then I printed a large print. This printed in under 2 hours. This is a vase mode rocket. It is a gorgeous, gorgeous print. It is really a nice print. But then I wanted to do something that was hard, that I've done on every other printer. Now, generally I print the full Kickstarter test model, but I've already done an overhang check and that worked great. I know clearances seem to be sizing, extrusion seems to be pretty good, and the dimensions seem to be right. So I printed the top of the Kickstarter test, and there was a lot of stringing. Now, I'll show you a picture of this along some other tests up on the screen in a moment. The stringing is really fine, just really fine stringing, something you could easily pull off. It's almost like cotton candy. Now, I printed the same thing on the Ender 5S, which I'd reviewed just a little while ago, and it had the exact same phenomena. At the very top, there was a lot of stringing on this model. And if I recall, on the Ender 3S Pro 3D printer, which also is an all-metal hot end, I had fine stringing at the very top of these prints. So it seemed like that was a characteristic of all-metal hot ends. Not terrible, because it doesn't impact, we'll see, any other prints. But it still bothered me, so I printed a whole bunch of these little tests at different temperatures. I printed some specific test elements. There's a plugin for Cura for calibrating your printer, for eliminating stringing, and the various settings, other than temperature, didn't really seem to matter a lot. More retraction, less retraction, higher speed retraction, slower speed retraction. I ended up going back to the default, dropping the temperatures about 5 degrees Celsius from 210 to 205. But then I remembered that maybe it's my filament, that filament can be causing the problem. So I did two things. First, I put a roll of filament, a real filament, in a filament dryer overnight. I tried that, didn't make a difference. This was Hatchbox white PLA. Then I switched completely. I switched to MatterHacker has a filament called Build PLA. And I got almost no stringing, but just a little bit. But I actually didn't print this first. I printed this one second. Now, in order to get prints off print surfaces, without taking the print bed off, now these come off easily, they're spring steel, that works, but I've often just taken and put a big fan I have here in front of the print surface. And in like 2 minutes, the print surface will drop down to about 19-20 degrees Celsius, which is cool enough to remove the prints. Just pull them right off if it's a high quality print surface. So when I printed the first one of these, I actually had forgotten to turn the fan off. And interestingly enough, there was absolutely no stringing. So an interesting thing I'm going to have to test some more for another video is making a whole bunch of prints that often get some stringing and adding extra fan to the outside of the printer. So just an interesting curiosity. But then I printed a really interesting print that tested a lot of things about the printer, and you see examples of this. And this is a very tall print. This will not fit in my Ender style printers. It'll only fit about this much in the Ender style printers. This is an Eiffel Tower from Thingiverse it was the Thingiverse Eiffel Tower for the Ender 3, but I blew it up 150%. It's a beautiful print. And their only place there's anything like stringing is under here, this overhead that is completely horizontal. Obviously there were some adhesion problems because there's some stringing inside there that's hard to see. Actually, there's a little stringing on this overhang also. But overall, this is just a beautiful, beautiful print. And these are two examples of things you can print on very large printers that are fast. So the question is, how fast? Because we've demonstrated now that we can get really good quality, even at high speed, off this printer. So how fast is it? Well, this Eiffel Tower printed in 15 hours. So it wasn't a quick print, but how long would this take if I printed it on one of my other printers? Well, I don't have an Ender that's big enough to print this, and I wanted to print something close to this. So I have a JGMaker Artist D, which while it's an IDEX printer, has similar characteristics to the Ender. It's slightly faster maybe, but not much. I could only fit it, and that's a big printer. I can only fit it on that printer at 145%, not 150%. And it was estimated to print at 25 hours. So compared to a traditional bed slinger style printer, print at 50, 60 millimeters per second, setting the overall speed at 400, but setting top and bottom down to 60, letting Cura adjust many of the other speeds to appropriate speeds, this was about 1.7 times faster. So that makes it even faster than my Ender 5 S1, which is also a very fast printer, but not quite as fast. So should you buy this $800 printer? It's really closer to $900. Well, the first question is one of space. If you don't need to print things this big, there are other printers. The Super Racer is a smaller printer from Flsun. The Ender 5 S1 is a wonderful printer from Creality. The Ender 3 S1 and S1 III are very good printers. The Solvo SX6, SX06, I believe, is about a $250, $280 printer that is an excellent printer also. Not as good as the quality of the S1 printers, not as good as the quality on this printer. So here's my conclusion. If you need both large print volume, you want one of the fastest printers available today, and you want excellent print quality all in one package, plus all of the advantages of Klipper, which give you remote access from a browser, this is a great, great printer to buy. Well, folks, I hope you enjoyed this. I had a blast making these prints. I've always wanted to print really big things. I was baffled by the all-metal hot end issues and now discovered that maybe it was partially just I was using the wrong filament, and that the MatterHacker filament, as an example, strings a lot less than Hatchbox. And I might have found a little trick here by putting an external fan on for items that tend to string a lot. So thanks so much for watching. You can go discuss this at forum.makewithtech.com. You can find all sorts of model templates you can customize at models.makewithtech.com. And please subscribe, click on the bell, share the video with your friends, and let's continue to learn things together.